Today, I will introduce AgentSysFilter, a multi-agent analysis approach for scenario-aware Syscall limitation. The goal is to reduce the kernel attack surface by generating Syscall allowlists that are complete and tailored to the actual service scenario of the target application. Modern operating systems expose hundreds of syscalls to user space applications, but a single application usually needs only a small subset. Existing static syscall analysis methods analyze the whole software and consider all possible execution paths, which helps preserve completeness. However, this also introduces many redundant syscalls because the analysis is scenario agnostic. Fine-grained reduction is possible by considering configurations, command line arguments, and service scenarios, but this usually requires expert knowledge. Users need an automated way to translate real usage requirements into scenario-specific Syscall allowlists. This work faces three main challenges. First, agents must analyze LLVM IR like human experts, including functions, global variables, debug information, CFGs, and call graphs. Second, we need to balance LLM reasoning with static analysis rigor. LLMs are useful for understanding scenarios, but program facts should still come from reliable tools. Third, the analysis must produce effective reductions, not just explanations. Agents should derive constraints that reduce reachable branches, APIs, and ultimately syscalls. To address these challenges, we design AgentSysFilter. At a high level, it uses LLM-driven agents, together with static analysis tools to perform scenario-aware Syscall dependency analysis. The key idea is to let agents reason about user requirements and service scenarios, while relying on tools to inspect LLVM IR and obtain program facts. In the first phase, AgentSysFilter takes LLVM IR, configuration files, and user requirements as inputs. Agents are equipped with static analysis tools to inspect IR structures, CFGs, call graphs, and debug information. The task manager decomposes the syscall reduction goal into specialized subtasks and schedules downstream agents. In the second phase, analytical agents work together. Static analysis agents recover program structures and reachable functions from LLVM IR. Scenario-related agents reason about how configurations, command line arguments, and runtime contexts activate code paths. Then, the Syscall dependency analyst maps scenario-reachable user space APIs to the required kernel syscalls. In the final phase, the policy generator synthesizes scenario analysis results and API to Syscall mappings. It keeps syscalls required by activated scenarios and removes syscalls only needed by inactive scenarios. The final output is a Sycomp BPF policy tailored to the target service scenario, reducing unnecessary syscall exposure while preserving compatibility. Finally, the demo shows AgentSysFilter in practice. The left side presents LLVM IR upload and task initialization. The right side shows multi-agent analysis results after execution. Through this workflow, AgentSysFilter provides an end-to-end solution that reduces manual expert analysis and helps users generate fine-grained Syscall limitation policies. This is the GitHub repository of AgentSysFilter. Here you can find an introduction to the workflow, including tool architecture and agent roles. The page also lists all the requirements for running the tool. Below that, we provide clear step-by-step instructions for installation and usage. In the backend folder, 4 core modules work together to complete the analysis task. The Workflows module handles task allocation, and the Tools module lets agents invoke static code analysis tools. The Agents module performs core functions like scenario and execution context analysis. Finally, the LLVM API to Syscall module gives agents the ability to generate Syscall policies. This video shows the multi-agent analysis workspace of AgentSysFilter. The system performs scenario-aware static analysis to reduce the allowed Syscall set while preserving program compatibility. First, we upload the LLVM IR file, cat.o.ll, and start analysis in the unconstrained scenario. The task manager then coordinates multiple agents to extract functions, call graphs, control flow information, entry points, arguments, and scenario-related paths. Next, the Syscall dependency analyst maps reachable allowlist and POSIX APIs to kernel syscalls. Finally, the generated Sycomp allowlist is opened and downloaded.